Hello, everyone. Good evening to all. So, guys, I welcome all of you to the day 5 of AI/ML Essentials program and a quick recap of what we studied in the last class. So, in the last class, we studied about reinforcement learning. We saw that reinforcement learning is a part of machine learning where the essential task is to maximize the reward. And we also saw an example in which there was an agent and a reward, and the aim of that agent or the goal of that agent was to maximize the award, clearing all the hurdles in between. Then we had a discussion over Q learning and Markov's decision. So I hope you remember all the important points of the previous session. And I welcome you, sir. I think we can start with the session.
Yeah, sorry for the delay, guys. Yeah, thank you so much, Gaki. Okay, so very good evening to all. And I hope that you all could remember the last session that we had about reinforcement learning. In continuation to that, we are going to discuss, something on deep learning. As we are very aware about the AI, so AI is actually exploring in a very deeper way with the help of the neural network structure. With this, neural networks, most of the complexity problems are going to be solved, such as facial recognition, object identification, and object tracking, and speech recognition, and classification of something, and which are all the it is not so easy actually. So while we just discussing, you might be feeling it is so easy, but when you are trying to solve, it is very complexity. So that's the reason why deep learning can solve all sort of complexity problem, the complex problems. So to that reason, so we are here to brush up something about deep learning. So I try to give as much as possible. I want to make you all understand exactly what deep learning is all about. All right, fine. So I hope that most of you had some basic idea about deep learning, and I also have given a introduction at the day one, what exactly the neurons, right? How the neural network have been comparing to the human brain system. That is what the human neurological function systems, right? So actually, the we are constructing the human neuron structure into the machine. That's the reason I will be calling it as a artificially you are creating a neuron structure for a machine as like a human. So I could refer it as a artificial neural networks. All right. So actually we couldn't say deep learning because deep learning is a word which as came out so recently. This would be the generalized term for a artificial neural networks. So I could say this as a artificial artificial neural networks. All right. So we'll first let us understand exactly what is all about the neural networks. Then we go and see the further things. The neural network, which is kind of a template, or you can say it is a kind of a structure in which every neuron should have the connectivity. Every other neuron, all right. The connectivity, I could say it is a relations, all right. So by which you can find out anything, you can solve anything in the real world problem, all right. That is what neural networks. So uh, like a human neuron system, everything is going to be represented as a neurons, but all the neurons should have the interconnectivity to each other. So in the neural network, I would say like perceptron. So there is a first term can be defined called as a perceptron. So you can see here what exactly the perceptron. The perceptron is actually, you can say, it is a processing unit. All right. So I could say if there was an input, let us take a simple logic, right? There was a A and B. Let us take there was a two integers. All right. So it is going to be taken, and there will be a computational logic. What is the computation we are going to have here is like addition. So you want to add two numbers. Let's define the computations. All right. So I could say it is the computation is actually a processing a block or init, and from which we would be getting an outcome. So if you assign this is 10, this is 20, then you'll be getting 10 plus 20. The outcome is going to be taken out from the this output node, right? So you can create the entire problem solving into three category. One is input, another one is processing, and last one is output part or block. You can just put the same conceptual block into the neurons. All right, so that's what the processing block here in terms of a deep learning or neural network, it can be referred as a processing unit. That processing unit so technically can be called as a perceptron. Now you can understand what exactly the perceptron is, a kind of a block in which the computation things are going to be defined. All right, that's it. So, and I have given one simple information to you all, like the Frank Rosenblatt is the person who has proposed the first perceptron in 1958. So that's why I've given. So you can just imagine the first AI was ignited in the year of 1958 by the Rosenblatt. All right, and what he has done very simplest task, right? He has created a neural structure in which the perceptron or neural network is able to classifying one or two, right? So he has created a classification perceptron. So he has created a classification perceptron, or it is a classification neural network model, so which would classify whether the given input is one or two. All right. So initially, and it was a linear classifier, which means that everything is going to be happen in a sequential way. Nothing can be done in a parallel way. So in the age of at the year of 1958, only linear classifier is the possible thing which was created, right? And even it can be used as a supervised learning. And you can just understand here, like the neural networks always try to solve the what it is, supervised learning problems. All right, because since every data has its own label, and with a label we are at, because there will be a target, right? So based on target, the things are being working. Supervised learning. Whereas unsupervised learning, there won't be any target. So we just note here, like the deep learning always being built uh, only for a target, right? So without target, if you simply build a network, there won't be any results in a neural networks. So 90% of the cases, it is solved only the target based problem. All right. So you just imagine like target based problem, facial recognition. What is the target over here? You should identify that person faces belongs to X or X, Y, Z. All right. And if you take a object deduction, whether a particular object is present in a particular place or not. All right. So it's all, there must be a target. So we have to specify that is your target. Based on that, things are going to be move around. So that's the perceptron. So I hope that you are understood the perceptron. So Meanwhile, I have given a small block diagram for your better understanding. You just look up here. There will be an input x1, x2, x3, and x4. Right. So, because in the diagram, everything was represented x1. Instead, you can take x1, this is 2, this is 3, this is 4. We have a 4 input. Also, all the input are going to be processed by what? Processing logic. The processing logic can be referred as a perceptron. Am I right? So this is actually the perceptron. All right. You could see here the inputs are processed, and because well, if you want to add two numbers a and b, we would be writing the logic a plus b that produce an outcome. Whereas here, let you assume that this would be the x1 would be the in a particular subject marks for a student. Okay, let us take mathematics. Mathematics marks. What is the mathematic marks? So it's going to be a 60. Here it's going to be 68. It's going to be a 75. It's going to be here is what? Like you know 45. So with this input, it's a mathematics marks for a one student. With this, you want to predict what is the mark he is going to get in the next grade of the classes. It's a kind of a prediction. and also, and this deep learning is going to be it's going to be applied for any type of problem. Even this can be applied for a regression problem. You can apply this for a classification problem. That's what I told. Mainly it is used for solving a supervised learning problem, because object tracking detection is also kind of a supervised learning. There will be a target, but the input was multimedia. All right, so your input was age or video and so on. Guys, give me a second. There will be a disturbance. I'll just come back. Just give me a few seconds. Yeah, sorry for the interruption. I'm back. Okay. So here, I'll be taking an example as to identify or predict what would be the mathematics marks in a next classes. So if you take this the 8th standard mark, 9th standard mathematics marks, 10th, 11th, you want to predict what would be the 12th mathematics marks. So the inputs are going to be taken, and at every, because since all the inputs can be called as a node here, actually you consider is a node. What is actually node? It is a neuron. So consider it is a neuron, because every information is going to be processed or read out with the help of the neurons. So the neuron can be referred as here as a node actually, right? So this is the input neurons, or you can say it is an input layer. Right? So all the input is going to be processed with the help of the perceptron. But what we'll be doing inside a perceptron is perceptron should be calculated, and every neuron, every input is going to be provided by some weight actually. What is the weight? Weight is always the assumption. Weight is actually the assumption based some input. So the neuron is thinking w1. So neuron provides, so 65 is the weight for the first input, and second neuron we have a second input 68. For that, the weight is going to be allocated by the your neurons is going to be a 75. For this, it's going to be a 78. Let's say it is a 69. You take here 45, the weight is going to be collected is 60. Then what would be the outcome of this neuron? So it is going to be gets added. 60 plus 65, what? Divide by 2. Let me, because this is the way is not actual neuron is processing. For your understanding, I'll be just explaining. 60 plus 65, 125 by 2, it is going to be, what is 125 divided by 2 average value? It's going to be a 125, it's going to be a 62, right? So you'll be getting 62 here. All right. And the Perceptron, this is the way the Perceptron are doing. The Perceptron is, substituting some weights of each and every neurons, every input. Then it is computing something, and the Perceptron will define some threshold level. What is the threshold? If this value, the outcome of this first neurons is it's greater than something, the neurons are going to be fired. If not, the neurons not going to be fired. All right. So as such, the prediction is going to be happen. You see here 62 comes here, and you can see here it is going to be 68 is the average, 75, 78 it is going to be 76. It's going to be 45 plus 60, the average is going to be 50. Then you just take all these. What is the outcome of the this perceptron? So 62, 68, 76, and 50. So this would be perceptron, and take the average of all the things. Let us assume that the average is going to be 63. So the neurons are telling you 63 would be the prediction value for the particular input, because this is an example for a regression problem. All right, but this I have been explained only for the understanding reasons. But how exactly the perceptron is working, you can see here I have given the basic processing logic of the perceptron. What is the logic? We have mentioned it Wx plus bias. You can see it, this is the logic Wi and Xi plus bias. All right, so W is the weight which has been provided by the neuron. That's okay. X is the input. What is the bias? See, the bias is actually which is very much important to have a better understanding about your assumption. All right. Always, you'll be assuming something. How the assumption is going to be happen? By providing some additional inputs. All right. That is what your bias. So bias is completely a assumption factor. This will strengthen whether this outcome is going to be more strengthened or not. So completely based on the bias. So there won't be any predefined value for bias. And as well, and very simply I could say the bias is error actually. All right, bias is error. So when you do everything in terms of assumption, 90% of the cases we used to get an error, right? Because our assumption is not going to be happen. Right? If all the assumption is going to be executed as you assumed, then there won't be any problem, right? In reality, that will not be happen. So that makes you an error. So that is the error component, right? So always we should include the error component when you are computing something, right? So then that is the Wi and Xi. So just take the 60 and 65, and multiply it and add the bias, and we have some kind of threshold factor here. All right, what is the threshold factor here? I'll be saying summation of Wx plus b greater than equal to 0, just return 1. If Wx plus b less than 0, return 0. This is the classification or outcome that I'll be defining. Accordingly, the neuron is going to be happen. So Wx plus b, which means the 60 into 65 plus bias, if that factor greater than 0, then you'll be getting as 1, right? So what is 1 actually? The neuron starts firing. The neuron starts activating, because it is a kind of activations, right? When the neuron gets activated, when the neurons is not going to be get activated, right? So this is what the component, the activation function. So as I said before, the neuron should get fired out, because if the neurons is not firing, which means that it is it is not processed, your input is not processed. If you are looking something, immediately your brain is thinking in different way. Because if you go to the it's a new restaurant, and if you look at some heatable items over there, but you are not yet come across, if you are not yet looked at that heatable items, then immediately your brain is started thinking what's supposed to be the heatable items. All right, that is what the activation. So immediately, because if you have came across that eatable items in somewhere in your lifetime, then the neurons is firing. This is that product. That is the this you would have been already tasted, which was you taken in somewhere else, right? So that's how the neurons is firing out. So that is the activation function which has to be required to come up. What is the Y cap? This Y cap is the outcome. Whether you can able to recognize the heatable items or not, whether your neurons is firing or not. If the neurons started firing, you will be recognizing. If the neurons is not firing, you cannot be recognized. Right? So that is actually the basic things of the perceptron. In perceptron there will be a single layer, which means that if you have only one processing unit or only one hidden neuron, it's going to be a single layer. Then you would have the multi-layer perceptron. You can have a look on here. What exactly the multi-layer perceptron? When you have more number of neurons are participating in the neural structure to classify you something, that is going to be the multi-layer perceptron. All right. So you can see your multi-layer perceptron defines the most complicated architecture. What actually the most complicated architecture? Which has more layer of the hidden neurons. So you consider this the input layer. You have plenty of inputs. This is hidden layer. This is the first layer of neuron. First layer of neuron. This is the second, phase of layer of the neuron. So your input is, if your input is 30, and this is the neuron L1, which means that level 1 neuron, L2, layer 1, neuron 2, it is the L10. You have 10 neurons. So this 30, input 30 comes here, then this L1 neuron provides some weight. The weight is actually the random assignment of the input. So based on the input value, this neuron is, providing the random weight. So the weight is going to be 35. So 30 into 35, according to the logic, what you are defining. All right. So 30 into 35, it will be computing and keep here. And how, whether this neuron is the value of the L1 can be forwarded into the next level or not, it's completely depends on the hidden layer activation function, completely based on the activation function. All right. So based out of the activation function, the neuron gets to know whether this outcome of the first level of neuron can be fired to the next level or not. All right, that's it. So what exactly the multi-layer in the sense, you'll be having more number of hidden layer. So since in the human brain actually there won't be a such kind of structure actually. So because it is completely miss, because we can't able to understand how the neurons has been connected in the human brain. But and moreover, we cannot exactly replica the human neural structure. That has never been possible. That's the reason why we are creating some standard or some template. Based on that, we'll be forwarding. We'll be constructing likely to be a human neuron system. So first level of and second level, and as well you can keep n number of neuron hidden layers. Right? Then you'll be getting an outcome. So what exactly the multi-layer? You'll be having more than one layer of the neurons, so that it can be called as a multi-layer perceptron. So at every layer, you can create your own activation function. So here you can have activation function 1. It is not necessary that you should have the same activation function in the hidden layer 2. You can create activation function 2. You can have the different activation functions. All right. Then you'll be getting an outcome. All right. So can you all able to understand? And I just have your, like, if you have any questions, kindly post it. Then we'll have a simple Q&A session for a minute. Just you can think.
Guys, please post all your doubts. May it be related to some other session also, like maybe from day 1, day 2, or day 3. So you can post all your doubts here. And one important information here, that we haven't assigned any assignments till this point. So don't worry about that. And for the exam dates, we'll let you know. Also, you can visit the community website for all your doubts, and you can even post your doubts there regarding exam dates or certificates. So do visit community website for that thing. I cannot see any doubts till this point. Everyone
Yeah,
is so much clear with all the questions. Yes, sir.
yeah, Garpi, no problem. We'll continue and we'll give a time for them to pose some questions.
Yeah,
Yeah, yeah.
sure.
Okay. So let's come here. What exactly the deep neural networks or deep learning? You can see here in the diagram, because which is not more clear actually. This is input. You have hidden layer 1, hidden layer 2, hidden layer 3, hidden layer 4, hidden layer 5. So when you are strengthening or increasing the hidden layer, then which can be called as a deep neural networks. That deep neural networks perfectly is, is called as a deep learning systems. That's it. All right. Okay. So now I'll be moving to some other slides. So, and I have just given the basic introduction to all of you, and you can just have a look on, this is the how the biological neurons are working. All right. So that there will be a dendrites, and which is the most recent thing wherein which all the signals are going to be received. Whereas in our neural networks, artificial neural networks, there won't be any such kind of signal receiving component. Everything is going to be considered as a input, because the input is already receiving. Already we have some input rate data, that we have a data. So with that data, something is going to be processed. So there won't be any kind of signals here. The signals that I can represent is completely input. And there will be a sensor. You can collect the data from the sensor. So that's the sensor based, deep learning system, somebody. And axion synapses. So you just Google it and you'll be getting, because this is completely biological term. So based out of this functionalities, we'll be defining the neurons. So this is how the human brain neuron structure is going to be. When you look out here, like every junction, this is actually the junction, because in a human brain there won't be any component as such. This is we have created only for the representation of the thing. So this is what I can call as a node. Right, node 1, 2, 3, 4, and so on. Every node will have the connectivity every other node. So that's what human brain forms a network. And single layer perceptron, you see your simple networks. That's what I have told. X1, X2, Xn. What this plays is actually, this is what neuron. Right? So perceptron. Here you do write some logic here. Right? So basically there will be a activation function. So don't worry about the activation function, because we have not yet seen anything on activation function. Just to have idea, activation function are the one which defines how the neurons are going to be triggered or fired out. So completely based out of the activation function, things are going to be done. All right. So and then the output is going to be coming out. All right. So the same example I have just depicted in the just before. You can see here W, I, and XI, and when the neurons are going to be fired, all right, or when things are not going to be fired. So this is completely activation function. All right. So what is if the if this gets 0, all right, there won't be any activation. So your things are going to be like this. If this component gets 1, which means that the computation of this things greater than 0, then the outcome is going to be 1. And after that, you will be getting, this is what 0, this is 1. Again, if you get 0, this is going to be flattened. If you get 1, it's going to be like this. Again, if you get 1, it's going to be like this. If you get 0, it gets flattened. All right. So this is a kind of a step function. All right. So what I'm going to do here is I'm going to represent here is completely based out of this activation, how it is doing. Accordingly, your outcome is going to be happen. All right. So decision boundary, how it is happening. All right. So I don't want to go because there will be a lot of things has to be discussed. So how the decision boundary is being created, and this is not a right time to talk or discuss all the this is what the core stuff of the decision. Right. I just want to brief you all. I don't want to take you into the complex things here right now. All right. This is what a multi-layer, very well. So if something is a multi-layer perceptron, it should be a fully connected. What exactly the fully connected? This hidden layer neuron should have the connectivity to all other. That's the fully connected. This neuron, if you take this one, it should have the connectivity with this. That is what fully connected layer. Yeah. So this is very, very important, and so far we'll be completely discussing activation function, activation function, activation function. What it is. So you can see a step function. That's what we have discussed, because I have taken only the basic activation function, step function. If your component, if the outcome of the some logic, what is that? Summation of Wi and xi gives greater than 0, the value is greater than 0, then it's going to be a 1. You can see here. If not, it is going to be a 0, flattened. That's it. So it is a step function. What is the sign function? So instead of 0, if you are defining, what is that? Summation of, this is what this u actually stands for wx, right? The value of wx greater than 0, this is 1. The same thing, wx, okay, less than or equal to 0 or less than 0, you could define it -1. So this will create a sign function. What is sign actually? The sign is nothing but your signals can travel from -1 to +1. That is what sign function. So which was the thing is going to be happen as such, and this was. So when you get your component value is less than 0, it's going to be -1. And if you get +1, it goes via the medium, and this part is the 1. All right. And this is what a sign function, and mostly guys like step function, sign functions, which is not used much. And there will be an identity function. What exactly the identity function? So it's going to be f of x is equal to x. All right, that is what an identity function. It is going to be happen as such. It will create some linear line, and you just come here. There will be a sigmoid function. What is the sigmoid function? You see here, this is what the component actually. All right, sigmoid function is, you can say, p equal to p. You can say it's a pi of u or anything. 1 divided by 1 plus e power minus, I can expand this u, it's a mx plus b. I hope you could remember, or you might be knowing what is mx plus b. Mx plus b is a line equation. All right. So if you substitute everything into this equation, people used to say it's a sigmoid function. The sigmoid function will produce an outcome from 0 to 1. So if you substitute any value in this function, this will create a outcome. That outcome will lies between 0 to 1. That's the reason why it will be created a sigmoid curve as like this. All right. So sigmoid function is very, very important for binary classification. All right. So 0 to 1. So they will be fixing some threshold level. So this threshold point is 0.5. So if there was some data points who was distributed as like that, you can say it is a star, and there was a certain data points was there plus. This plus and star is being classified with this marginal value called zero point 0.5. So 0.5 is the what I can say, it is a threshold value for the sigmoid function. If any of your input gets this sigmoid value as, what is that, p is greater than 0.5, that can be classified as star. If the p is less than 0.5, all the data point will be classified as plus. So as such, the neurons are triggering or neurons are firing out. I hope you got to understand how the neurons are getting fired out, completely based out of the sigmoid function. And let's come down here. The next one is the, you can say it is a hypertangent function, or in a short you can call or refer to the tan h function. Tan h, that is what hypertangent function, that is going to be referred in short as a tan h function, right? Tan h function is being defined as such. So whatever the thing you'll be, what is u actually? U, they have not actually elaborated. I can say u stands for mx plus b. So mx plus b is the line equation, m is the slope or coefficient, and b is the intercept value. All right, and x are the input. So it just compute m and b from this equation and put over here, and this the entire this component will produce a value from -1 to +1, because there will be a only difference of sigmoid and tan h function is sigmoid will produce the value from 0 to 1. It will not go and perform in the negative direction, whereas tan h function will perform in the negative also. That's what this curve is going to be like this. All right. So tan h function. So where you should apply tan h activation function is whenever you are going to get an outcome from -1 to +1. In that cases, you can make use of the tan h function. When the outcome of your inputs is going to be 0 to 1, then you might be use sigmoid activation function to process your inputs. And both sigmoid and tan h are a great classifier. All right. So that's what we keep all these activation functions. You are going to make use of the activation function in neurons. So if you have an input, and if there is a neuron, definitely this is the neuron, right? Computing neuron or perceptron. This should be specified any activation function. Without actual activation function, the neuron cannot be processed anything. Then you will be getting an outcome. All right. So if you asked, sir, this is the entire activation function? No, because I've just displayed only very few of the activation functions. You have a lot more activation functions, and that has to be essentially learned by you to explore you to explore in the deep learning environment. All right. So if you ask what are the rest of the activation functions, I could say ReLU. You can just search over the web, you'll be getting a lot of things over there. All right, ReLU, and there will be a L ReLU, that is what leaky ReLU, and softmax. All right, and the sigmoid tanet, that's it. All right. So these are the quite enough, quite sufficient activation functions which should be helpful for us to explore in the deep learning. And what actually feed forward networks? Because what is feed forward? What is feed actually? The feed is actually the input. Forward is what you have to propagate in the next level of the neurons. Right? So obviously, if you construct any neural structure, all right, if you think this would be the neural networks, internal neural networks, this would be the outcome, all your input goes here and similarly comes here, then this, because you'll be computing something here, right? This is the first level of hidden layer 1, this is hidden layer 2. So there will be some computation is happening at the hidden layer 1, right? So this computation outcome, there will be some outcome. This outcome should be forwarded to the next level of neurons. That is very mandatory, but it's an obvious thing. So this is what we could refer as a feed forward networks, because always the inputs are keeps on moving, or it should be propagated from the hidden layer to the hidden layers, and from the first level of hidden layers keep on forwarding or keep on moving to the next subsequent neural networks. As such, the computation is going to be happening. All right. So feed forward neural network, it is a just a network, neural networks, because all the neural networks should be forwarding their computational outcome from every level of neuron to other level of neurons. All right. That's what I've given you. You can see here flows through the function being evaluated from X. What is the X input? Through the intermediate computations. What is the intermediate computations? The hidden layer is computing something. This is what perceptron. What is perceptron? Is a processing block or processing unit. And finally, it will be taken into the output layer. That's it. And there should be any feedback connection in the entire network, because if you are computing something here in the hidden layer 2, there won't be any feedback to given to the previous layer. What exactly the feedback is? What actually feedback? If I will be taking a session for you to make you all understand in terms of a deep learning, all right? So at the end of the sessions, we'll be collecting a feedback. Why? To improve the performance. So if something is not understandable, uh, since what is the fact of things? Because the mentor, it is not delivering properly. So if you are giving a feedback, and based out of that, I'll be fine tuning myself. That's the feedback, right? The similar way, the outcome of some computing, it's going to be forwarded back or given back to the first level of neurons. It will fine tune in the computing things, all right? Because as you can simply understand, like, so if I'm not performing well, if I'm not delivering to you in the right way, you can give a feedback to the team, and team will be conveying to me, sir, they are not understanding, you are going very fast, or you are taking you what you delivering which is not understandable to the audience. So you'll be telling things as so complex. So as such, you are providing a feedback. So based on the inputs, I'll be correcting myself. So at last, what would be the takeaway? If I'm correcting myself, then the audience are getting benefited. So everyone is started understanding what I'm trying to deliver. That's it. So as such, the feed forward neural network doesn't have any feedback system. It never takes the feedback. That's because if a network has such kind of a factor or properties, then I could say it is a feed forward neural networks. All right. And this is what already we have seen. Yeah. And one more thing, this is the very, very important tricky in the deep learning, how the perceptron or learning, right? Always the learning happens when you made mistake. Am I right? So from the mistake, things are being exactly computed. Why I'm not succeeding? Why I'm not learning effectively? So first of all, we have to identify the lacks of the learning, which means that the error. Always anyone should identify their mistakes. because if the people never encounter their mistakes, they cannot success in anything. Even if it is a learning or if it is a business or if it is anything, right, they cannot success. So you have to quantify your mistakes, then you have to apply your quantified mistakes or errors by which you can improve yourself, right? So how the error is going to be measured? The ultimate aim is, when you want to improve the perceptron, when you want to start learning things so greatly, you have to identify your error. All right, so your error. So how the error is being computed? So always the error is simply, I could define the error is going to be what? Actual and predicted. Actual and predicted, right? That is what error, because you'll be knowing something. So you are expecting, because you have been predicted, and tomorrow, fuel price. Let's take a fuel price, right? Fuel prices, you are predicting today what would be the fuel price on day after tomorrow. That would be the 90. But when you are reaching on the day after tomorrow in live, then the actual price is going to be recorded as 88. Am I right? But there will be a difference, right? Because your model is predicting something as 90, but actually the happened event was 88. So how the error, the difference between the actual and predicted, it is going to be 88 minus 90. What it was, error is going to be -2. And just think, can we say anything as a error as a -2? We can't say. If the error term is, at least you should say error is 2, 4, something like that. You can't say -2. Right? Always the error component should be saying in terms of a positive value. So that's the reason why you could see here, this is what the target. Tk is nothing but target value. Yk is nothing, yj or something like that is a output value, right? The difference between the actual and predicted was error, because we shouldn't specify the error equal to -2. All right. So when you want to remove this minus or negativity in the error term, what you should do it? You should, if you square this -2 square, what will happen? -2 into -2 minus into minus plus, you will be getting 4, right? So this minus gone. So in order to eliminate the negativity in the error of the perceptron, we'll be squaring down. So that's the square. That's what this formula takes, square component here. So this is what you say it is an actual. This is predicted. All right. But again, there will be a problem in this outcome, because 4 is not the actual error quantification, right? The error quantification is actually the +2. Sorry, 2. We have exploded as a 4. So when you want to shrink the value back to the original value, what you should do it? You should take the square root, right? If you take square root of 4, what is the outcome? 2. We can see now the error is -2, and now I get back as a +2. That's it. So that's the reason why the error component is going to be defined here. This 1/2 is nothing but square root. You can write this error E equal to summation of I equal to 1 to n, because here they have been taken as k. You can take I. I is nothing but for all the data points. It's going to be square root of tk minus yk. That is what I, ti minus yi, that whole square. So this is the way you can say it's a error term. In a deep learning or in a AI, we never say it's a error. We used to say it is a cost function. We used to say it is a cost function. What we'll be saying, like cost function. All right. So cost function is a error quantification factor by which we'll be identifying what was the lags in the perceptron. So if the error is high, then you are neural networks, neurons are start learning more and more. How the errors are going to be reduced by providing the weights in a appropriate way. And you can ask, sir, how could, because if there is an input, all right, there will be a hidden layer. This is output, right? So it is an input. So you can ask, sir, first the computation is starting. After getting an output, we will be quantifying the error. The error was like 30%. But after that, how the error is going to be reduced? How the errors are being calculated purely based on the weight, right? W1, W2, W3. These are the weight. How these weights are going to be given completely randomly. All right. And when I have the more cost function, if I change the value of these weights, obviously there may be a chance to reduce the error, right? So that is what weight updation. So weight updation. So now I could, at least you could able to understand, based on the error, the neurons itself adjusting or updating the weight of the, your inputs accordingly, the the error term are going to be minimized. So when the error is minimizing, obviously, you know what, the performance are going to be maximized. That's it. All right. So then I've just told you how the Perceptron is learning. Now, what exactly the delta learning rule? And this is very, very important. Derivatives. All right. Delta learning rule. Delta stands for derivatives. So we should take the derivatives of the error component. All right. You can see here. So what exactly, how the new weights are going to be assigned? I have told you, like, I take the input, we take the hidden neurons, that is the outcome. So initially the weights are given 10, the input was 20, the next neurons is providing is 25, this one was give, this neuron 3 is given a weight as 15, and the outcomes are coming out, we get outcome, but the error term you got 40%. Right, but 40% of the cost function is very high, right? You have to reduce it. So how do we reduce it? We have to update the weight. Instead of 10, you may give something. So how this new weight is going to be calculated? That's the delta learning rule. So this component is the weight updation, or you can say new weight. How the new weights are going to be taken based on the current weight. So you have to specify the current weight. This is what current weight. What is the current weight? Actually 10 in this problem. It was 10 plus this is the actual component you have to find out. Completely based on this only the new weights are going to be given. This is what the derivative component. So I have just explained what is the derivative component. This is the minus n dou. What is the dou? Partial derivatives of e. What is e? Your error term. So minus n and partial derivatives of 40 divided by derivative of v of jk. What is this v of jk? The current weight. What was your current weight? 10. So if you solve this problem, right, this n stands for like learning rate. It's a learning rate. So learning rate you should specify. So based out of the neurons, you have to specify what would be the learning rate. Right. So if you substitute all the values here, and you will be getting the delta value. Okay, if you substitute here, if the delta value, if you will be getting 4, then 10 plus 4, 14. So 14 would be the next weight. All right. So that is this is the way the weights are going to be updated by the neurons. All right. So you've got to understand how the new weights are going to be done. And before that, Gargi, do we have any quiz sessions right away?
Yes, sir, we do have quiz session today.
Yeah, of course. So let's go for a quiz. Once the quiz is done, and we'll be continuing with that. And meanwhile, if you have any doubts, you can keep thinking and posting it. And after the quiz, I'll be answering all of your questions. Is it perfect, Gargi?
It's perfect, sir.
Yeah, we go for a quiz.
So guys, like I can see many of you have doubts regarding the certificates, right, of the previous batch. So for that, like I will confirm once with the team that whether the certificates for all of them are issued or not, and then we'll let you know. Okay. And a quick instruction for the quiz that please be active during the quiz. Please try to answer as many questions as we are asking at that time. And please just post all your doubts from the quiz in the chat group. Also, you can visit our community website for posting the doubts of the quiz as well. So I'm just posting you the link of the quiz. So I've posted the link of the quiz, guys. Please check it. Yes, the certificates of this course will be issued after the course completion and after you have given the exams. Okay. Uh, One more instruction, guys. As soon as you finish your quiz exam, then please post it here that you are done with the quiz. Okay. Those who are securing first, second, or third position can post it here that at what rank you are currently in the quiz. No answers still yet. I think the quiz is quite tough for everyone. No one is done with the quiz. Guys, come on. Those who are securing first, second, or third position can just post it here that they have secured first, second, or third position. Okay, we have something. Okay, Harshvardhan has secured first rank. Nand Kishore has secured seventh position. Good. Okay, Harshvardhan, all correct. Good. What about others? What about the second and third position holders? Guys, if you are stuck with any question of the quiz, please report it here. Okay, Ayushri has secured second position. Congrats. I think there is no doubt with the quiz questions. Those who are done with quiz can just post it here that done or a thumbs up. Congrats, Mona. Okay, Vishal is done. And Kishore done. Mona done. Artrika done. I think most of you are done with the quiz. Only the person who has secured third position is left to post. Okay, no problem. Sir, I think we can restart with the session because many of them are done with the quiz.
Sure, Gargi.
Yeah.
Yeah, guys. So you got refresh. So keep on, listening. A theoretical part is always toughest thing. That I agree.
I think,
So
sir, we
that's
have
what.
few questions also.
Yeah. Please.
I was just noting the questions. Just a second, sir.
Yeah.
The first question is from Archika Banerjee. It's that the is this is the point estimation, the prediction part. So basically, when we are going through prediction, was that point estimation? She's trying to ask that, and
Yeah.
after that, yes, sir.
Yeah. So, Aritika Banerjee, point estimation, I've just taken an example to demonstrate how the neurons are working. But in real time, neurons are completely using or completely functioning based out of the activation function. So, what activation function you are defining to the neurons, accordingly, the neurons are going to be fired out. So if you are asking the point estimation or prediction part, of course, it completely decides by the activation functions. That's it. Any other questions?
Also, sir, we have one more question from Misha. That is this all different from memory perceptions? Like whatever perceptrons and multi-perceptrons we have learned till this point, is it all different from memory perception? She's asking that.
Yeah, of course. So, Mija, like whatever we'll be discussing so far, the neuron do not carry any memory, which means that the neurons do not have the. You can see here. 1 minute. So if you take this neuron input, if you consider this is the hidden layer neuron, this is the outcome. The inputs are processing, it takes an outcome. So input and output. As of now, this is a single layer perceptron. So this neuron do not remember any of the computational factor in it. So this neuron do not have memory, no memory in it, which means that it cannot recall what have been done previously, right? So that's the problem in the perceptron. So you are asking about the memory perceptron. So memory perceptron, it's completely different from the normal perceptron. If you consider it as the normal neural networks, the neuron do not have the memory. So when the neuron do not have the memory, if the input is 10, the first level the weight is given 20, here it is 10, the computation is going to be 200 here. Here the computation is going to be 100 here, and based on that you'll be getting some outcome. It is going to be 15. But when you want to when you want to use back propagate, because this is what the prediction, but actually the happen is actually 20, but there will be a cost function, right? So in order to reduce the cost function, we have to update the weight, right? So this neuron couldn't remember what is the weight I have just done before, right? That is the problem in the normal perceptron. So this can be solved with the help of LSTM. LSTM. What exactly the LSTM is? Long short-term memory. Long short-term memory. So when you use LSTM based perceptron or LSTM based neural network, then every neuron could remember the past happenings, so that it is very easy to update the weight. As such, the cost function are going to be minimized. The cost function in the sense the error are going to be minimized. That is what back propagation I have mentioned here. So when you want to back propagate, so which means that the cost function should be given to back to the neurons. So based on the error, further the weights are going to be optimized. Got it, right? You can see here, first calculate the error. If you feel this error is minimum, then you don't need to update the weights. If you feel this error is not minimum, if you feel the cost is very high, then update the parameter and go back and go to the model again, update all the things. So when you want to update the weights of the previous process or previous step, if the neuron has the memory, it is very easy to update the right weights. All right, that's what the things are going to be happen. I hope I have been answered for the questions. Is there any other questions? You can post it.
I don't
Okay.
think so. Most of the
Yeah.
questions are done. Yeah.
Yeah, great. So, guys, I can stop just brushing about the deep learning, because still we can speak many more things, because uh, you know time is not sufficient for that. So, I have something to share with you all, like how the platform has to be created when you want to work with the machine learning algorithm or anything machine learning deep learning. So I'll just show you what are all the Python packages are needed when you want to work it, how the platform are going to be created, right? I just want to share with you all. So give me a second. Okay, and before that, yeah, I'll take a few minutes of time to tell you about NLP. What exactly the NLP is? Natural language processing. Because so far we had a discussion, came to know, like how the numerical data or how the multimedia data are going to be processed or analyzed. But what about text? If you have text, hello, this is Ram. All right. So if you put how may, the rest of the words are going to be filtered. How may I help you? All right. So how this sequence of sentences are being created? All right. That is what completely we have to analyze the what text by which you will be coming out some insights. All right. And sometimes you have social networking, because now all the products have been reviewed in a textual way, right? Because if you have been received or ordered, or if you bought anything from the e-commerce, then you'll be reviewing it, right? So you'll be sharing your feedback about the product or delivery or anything. So all it's going to be text. So I want to know the general opinion of the particular product, because the millions of users have bought the product, but I cannot go and read all the reviews. All right, so instead, if I'm going to, I'll be creating a model. That model will capture all the review statement, and consolidately it will be creating a some sense on whether the product is good or bad, good, worse, or average, or anything. That I'm going to capture the sense of the text actually. That is what sentimental analysis. What exactly the sentimental analysis? So we are here to capture the sense of the review. The sense of the review is whether the review is good or bad or worst or what, right? That has to be extracted. So when you want to apply such kind of, when you want to solve such kind of problem, you should use NLP. So this NLP is just a pre-processing. So you take the text is going to be processed, and it is going to be converted as a numeric. Right, it is being converted as a numeric. Conversion of a numeric of your text is actually encoding. Right, so after converting encoding numeric, you can classify or predict, or you can do whatever you want. So NLP alone you cannot do anything, right? You have certain limitations or certain functionalities that you can perform, but when you combine or when you make use of the machine learning algorithm like classification regression along with the NLP, that might be solving a lot of problems, right? So that is what NLP. So NLP is the common thing for the entire AIML, right? So when you want to analyze or when you want to capture the sense of anything, you go with the NLP concept, right? That's it. That's it about NLP, right? So a lot of things are there, and we have a lot of tools to know to work with the NLP. You can see here, I've just mentioned a few tools: NLTK, Spazi, Jensen, TextBlock. These are the NLP framework, Python framework, Python package. So by installing this, you can work with a text. Fine. So last but not least, you should know, I have just given for your better understanding, when you want to work with the machine learning, what are the Python packages you should install: NumPy, SciPy, Pandas, Matplotlib, Seaborn, Plotly, sklearn, and Pill. So NumPy is the numeric computing, SciPy is the scientific calculation you can perform, Pandas is the data exploration, or you can perform some little bit of EDA, and Matplotlib and Seaborn, it's a graph visualization. Even include the Plotly. Plotly also visualization. sklearn is the actually the algorithm. All the algorithm was defined in the sklearn. You can make use of it. When you want to make a deal with the image in a very basic level, use the pill package. Pill is nothing but pillow package. Pandas is data handling, and SciPy is scientific. NumPy is actually the array handling or array dealing. So these are the very essential you know packages used to build a machine learning models. Of course, Kashif is saying sklearn is used to have ML models. Definitely, because all the machine learning algorithms is defined and kept you as a module in the sklearn. So when you want to call any algorithm, you should import sklearn, and from which access the algorithm. And reports accuracy, etc. Absolutely, Kashif, like what you are telling is everything is fine. And the next thing is deep learning packages. So when you want to work with the deep learning, TensorFlow, Keras, OpenCV is the must, right? So Keras is the abstract class or wrapper class about on top of your basic thing. And instead of TensorFlow, you can, because TensorFlow is the completely deep deep learning framework, deep learning Python packages. So We can talk a lot more on it because that tensor is something, but it will deal with the metrics of values. All right. Yeah, of course, Avijit, you can use PyTorch. Sorry, I don't know. 1 minute. It's gone out. Yeah, right. So you can use PyTorch, Tiano, and etc. All right. And OpenCV is for to deal with the image and video. And for NLP, NLTK passage HMAS is set. All right. That's it. So these are the packages it must be needed. And when you want to install, go to the anaconda.org and download the Anaconda framework and install it, where in which it will become automatically. So, and certain packages will not be there as a inbuilt packages. Cburn will not be there. You should install. How you have to install in the Anaconda is pip install the package name sklearn. So give as such, you can try to install all the packages, keep it with you. Yeah, of course, Bokeh is a deep learning library, Kashif. There is no doubt in that. So I've done my part. Is there any other questions? I can answer you all. So any questions? Kashif is asking in Anaconda, Conda install package name. Yeah, that too allowed. Instead of pip, you can use Conda. Both will be using to install the packages. All right. So either of the thing you can make use of it. So any other questions, guys? Okay, Gargi. So let's wait for a couple of minutes. If we get any questions, I can answer them.
Sure, sir. Guys, come on, any questions from the session or anything else? Except for the certification, of course. So we
Gosh,
have a question. Yeah.
I have seen that questions. So, will PhD in AI is a valuable one? See, the research aspect, like if you want to explore your career in terms of faculty at any university or something else, you can claim the PhD. But in terms of if you have an interest to work with the corporate or any industry, and PhD is not required. All right. So if you have the idea, if you have the skills, you can work it. But uh, in a longer way, if you want to go into the very very superior level, like if you want to be the head of the AI team, or if you want to be the some kind of the biggest level, then you can go for a PhD. But as a fresher, but PhD is not required. But the PhD is only useful if you want to work any kind of university or any colleges. If you want to explore your career, definitely PhD will be helpful. Even if you got a PhD in AI, now university are hiring the people. It's in a very very significant way. So you have the good futures even in a faculty or at any university in India or abroad. You can get it. So as of working with the industry, PhD is not mandatory. All right. So if then how and what is the roadmap, sir? So Kashif, like if you want to do your research in terms of the artificial intelligence, you should possess the masters. And basically, like if you are an engineering graduates, it would be a great enough. You can apply the research at any universities. So as of my knowledge, like you can go to the IITs. You just try to visit the IITs and NITs websites, and you can, because there will be a separate call for has been created, and you can apply, and you can go and take up the interview, and if you have been cleared, then you'll be provided a research scholar. So once you have been admitted as a research scholar, you'll be getting a stipend. I think the stipend is good enough. And now actually from the current year onwards, for a research scholar, the stipend is providing 35K, only the stipend. So you can go and explore as such. And only not only the IITs, you can go for any universities, right? Universities, and even you can go for a overseas also. There will be a lot of opportunities. If you have a skills in terms of AIML, you can get it. And Kashif, like GATE is not enough, because GATE is not required, because GATE is only for the masters who are trying to get an admission in IIT, NIT. GATE score is used for a research scholars, or if you want to get admitted as a PhD, GATE is not required. I think so. Out of my knowledge, I'm telling. You just go and explore it. Yeah, you can go for international universities. So, any other questions? Which language is better, Python or Scala? And go with Python. Always Python would be the good enough in terms of very special in terms of AIM. And Sai Nandini, uh, Nand Kishore, your question is answered. And Sai Nandini is asking, sir, for exam preparation, because tomorrow we have not the class. Of course, tomorrow we don't have class. Yes, any questions? And guys, regarding exams, assignment, you can approach Gargi at any point of time. So she is the single point of contact for all sort of things. Yeah,
Sir,
Gargi.
I think we can wind up with the session. Like, I think all the doubts are cleared now.
Yeah, exactly.
Yes, sir.
Kind up.
So, thank you so much, guys, for attending the session. A quick recap of the whole session. Today, we learned about neural networks, deep neural networks. We learned about single perceptron network, then multi-layered network, and then we had a discussion over activation functions, types of activation function, which is better, and what should be used at which situation. Then we also discussed about different packages available with us for solving algorithms of ML, deep learning algorithms, or NLP. And then we like discuss that how can we install those packages. So guys, an important instruction here that if you want to clear all your doubts regarding the certification or the dates of the exam, please visit our website. You'll get all the like updates from the website about the certification and also about the exam. Also, if you have any doubts regarding the session or anything else, you can visit our community website, and there you'll get all the answers for that. So thank you so much, sir, for providing the valuable information. Thank you so much, guys. And I think we can end the session, sir.
Yeah, thank you so much, Gargi. Bye bye.